Hi. Good evening, all the participants. Am I audible?
Yeah, sir.
Yes.
Okay.
Yes.
Yes, sir.
Okay. Thank you very much for giving me the opportunity, Hitesh. This is uh, right now. Today the sessions is on fluid mechanical Cesa is into the software imparting software trainings since 2004. And now college also have courses to Bentley to Cesa, and 65 questions, which is 100 marks. So as told that there are two types of questions, which is multiple choice questions, which is MCQ, and numerical answer. Is also which is that is multiple choice questions. There are like 1 mark questions and 2 mark questions which are asked in the gate. So for 1 mark MCQs, if you do wrong, then 1/3 marks will be deducted for every wrong answers. So likewise, if you have 2 marks MCQ, 2/3 of them, if you are doubly sure, or if you have practiced these questions and through our coaching, so that if you're sure of this, you can attempt this, so no taking chances for okay. So here we have different sections here, 5 sections. Out of this, I would be concentrating on section 4, which is water resources engineering. Here, the fluid mechanics is a very basic part where a lot of questions can be expected from properties or and momentum equations will be dealt with, so that a lot of questions do come in these chapters. Though because you have studied fluid mechanics right in the 3rd semester and hydraulics in the 4th semester, especially you have to concentrate more on open channel flow, because a lot of questions do come on open channel flow. So you know that in fluid mechanics, generally 13 to 15 marks total. Water resources about 13 to 15 marks, which is 15% of your to see that how we will continue with the sessions here. Just to give the glimpse of the teaching that we used to do. So generally in the gate papers, how the preparation should start. The preparation should start like that we are giving the concepts, because without understanding the concepts, you cannot do the MCQs, or you cannot even attempt the numerical type questions. So therefore, the more stress will be given on the fundamentals. Uh, so you know that just to give a glimpse of what we will be teaching today, will be just a 15 minutes lecture where I will be just to know about the way of teaching. So I will not be using any blackboards or nothing like that. So I will be more concentrating on this PPT type of lecture, where you will feel very comfortable when you listen to these lectures. There are various important fluid properties, particularly which we concentrate here. So like mass density, whereas we have the specific weight, specific volume, specific gravity, like this, and a lot of there may be 1 or 2 questions on this. So you know that the mass density of a fluid is the mass it possesses per unit volume. So the mass density is is represented by a symbol rho. So mass density is nothing but the mass it possesses per unit volume. So that's why it is mass density is mass by volume. So now we are referring SI units. In SI units, you know that we always express in MLT systems or FLT systems. You know that mass is represented as the unit is kgs. Okay, then the length is in meters, time is in seconds, the force will be in newtons. So therefore, this is the thing. In MKS unit, mass is metric slug, then length is meters, then time is in centimeters, then time is in SI units. That's what you learned in your BE days. So dimensionally, so when you write in MLC system, so mass is m, volume is length breadth into height, that is L into L into L. So therefore represented as m by L cube, which is ml minus 3. So now why these dimensions are written? The dimensions are written because you can express that in the units. So what is mass represented in SI units? It is kg. Volume is meter cube. So therefore the unit will be kg per meter cube. So therefore in MKS units, the mass is represented as metric slug. So it is metric slug per meter cube. So standard value of mass density of water is 1000 kg per meter cube. So 1 kg is again if you can represent this, you can also represent in metric slug, because you know that one metric slug is 9.81 kgs. So now you can, if you divide 1000 by 9.81, you will get 102.5 metric slug per meter cube. So this is the standard value of mass density of water, which is 1000 kg per meter cube. So that's why in the problems and all, you should know that the standard value of mass density of water. So now, how does mass density varies? This is the very important questions generally in the objective types or a multiple choice questions will be asked. So now you know that how the mass density will vary with the increasing temperature and increasing pressure. Suppose you take a particular volume. So you know that it consists of a lot of fluid molecules. When you try to increase the temperature, so what happens when you try to increase the temperature? Say for example, some mass, there is a lot of molecules. So molecular activity, there is a lot of molecules like this. So when you try to increase the temperature, so this molecular activity increases, and then some mass will be driven out of this particular molecules, will be driven out of this particular volume. So therefore, with increasing temperature, what happens to the mass density? Mass density will decrease. So now, so when you have fluid molecules here, so when you try to increase the pressure, so what happens when you try to increase the pressure? You are bringing in some molecules inside this particular mass. So what happens to the mass? So mass will try to increase. If mass increases, then the mass density will increase. So this is how this happens. That's why this is the question often asked, many a times asked in the gate. So mass density here, because I told you that with increase in the temperature, molecular activity will increase. So therefore, thus forcing the molecules or fluid particles to go away from that particular volume. So hence mass density will decrease. So with increasing pressure, what happens? You are trying to push in the fluid particles into the volume. So therefore, the mass will try to increase. So therefore, that increases the mass density. So now you have also a specific weight. So what is specific weight? So specific weight is the weight that it possesses per unit volume. So now weight is nothing but a force unit. So how weight is expressed? So weight is expressed in newtons. So the volume is expressed in meter cube. So unit will become, so this is how you write the units. So Newton per meter cube. So now the specific weight is weight by volume. So you also know that the like dimensionally you can write. So there are two types of system here. One is called the MLT system, other is called the FLT system. For writing in FLT system is very easy, because FLT, because weight is force, so it's force by volume. So when you write in FLT system like force by volume, so force is expressed as Newton, volume is expressed as meter cube. So therefore the unit becomes Newton per meter cube. So in SI unit, specific weight is nothing but Newton per meter cube. But in MKS, the force is represented as kg force. So therefore, it is in MKS units, it is kg force per meter cube. So don't worry about MKS units. So we'll concentrate more on the SI units. So now the specific weight is the standard value for water is 9810. Why it is 9810 Newton per meter cube also I will tell you. So now what is specific weight? Specific weight is weight by volume. What is weight? It is mass into acceleration due to gravity. But mass divided by volume, we already learned that it is mass density. So now you know that the standard value of mass density is 1000 kg per meter cube. If you multiply by 9.81, it will become 9810. So if you substitute in kg meter second, automatically the unit of specific weight will become Newton per meter cube. So therefore, the standard value of specific weight of water is 9810 Newton per meter cube. Or else you can write it as 1000 kg force per meter cube, which is your MKS unit, which you don't concentrate here. So therefore, there are two ways of calculating specific weight. So please remember, you can, if you have a notepad, you can note it down. Specific weight is weight by volume, one way. Specific weight is also mass density into acceleration due to gravity. So therefore, you know that already I have told you how mass density will vary. If the mass density varies, specific weight also will vary with increasing temperature and increasing pressure. So there's another term called the specific volume. Specific volume is nothing but for the liquids, it is the reciprocal of specific weight. For gases, generally the molecules are there. So therefore, we say that gas molecules, we say that it is reciprocal of mass density. So therefore, here it is nothing but volume divided by weight. So it is a reciprocal of specific weight. So like this, you can calculate specific volume, which is reciprocal, means since specific weight is Newton per meter cube, here it is meter cube per Newton. So similarly, now we come to what is known as specific gravity. So now this is a very important property. So now you take water and you take oil. So you feel that water is heavier than the oil. So there is some comparison between two liquids. So when you do the comparison between two liquids, and that property which is used is known as specific gravity. You know that mercury is very heavy. Okay, whereas water, when you compare with water, water is lighter. So if you try to compare between two liquids, a property that is used is known as specific gravity. So what is the property that leads to the weight? It is a specific weight. So now if you take mercury and find out its specific weight, okay, and take water and find out its specific weight, take the ratio of that. So when you take the ratio of specific weight of mercury to specific weight of water, so then we get a term which is known as specific gravity, which is 13.6. So that means mercury is 13.6 times heavier than the water. So for example, if you take oil, where we measure the specific weight, and take water. So if you take specific weight of oil and divide by specific weight of water, so we get something like 0 0.8, 0 0.85, 0 0.9 like this. That this shows that the oil is, or a petrol is lighter than the, so that's why it floats on water. So this is these ratios are known as the specific gravity. So why we measure with water only? Why we compare with water? So water is a standard fluid which is taken for measurement. So therefore, since specific weight is rho into g, so g is a constant for a particular place, so you can also take the ratio of mass densities also. For example, if you take mass density of mercury and take mass density of water and divide one by another, you'll get specific gravity. So this is one way of, so either you take specific weight of that particular liquid and divide by specific weight of water, you will get specific gravity, or take mass density of the liquid and divide by mass density of water, you will get specific gravity. So therefore, now since it is a ratio of the same quantity, specific weights, that therefore it is always a numerical, the pure number. There is no unit for that. So therefore, now you can say that specific gravity of any liquid is specific weight of that liquid divided by specific weight of water. So now this is one way of calculating. or also you can take mass density also. So specific gravity of any liquid is also, because specific weight is rho into G and G cancels out. So it will reduce to mass density of that particular liquid divided by mass density of water. So okay, so like this you can always calculate the specific gravity. So now I already told that what is specific weight? It is weight by volume. Specific weight is also rho into G. So there is one more way of calculating specific weight. If you want to calculate specific weight of oil, so then you take specific gravity of that particular liquid, that is oil, and multiply by specific weight of water, that is 9810. So then you will get specific weight of particular liquid. So there is also another way of calculating mass density of any liquid. So take its specific gravity and multiply by mass density of water. So mass density of water is 1000. So simply multiply by 1000, you will get mass density of any liquid. So this is what we are finding out. So therefore, now you can say that the specific weight of any liquid is take its specific gravity and multiply by specific weight of water, which is 9810. For finding out mass density of any liquid, take its specific gravity and multiply by mass density of water, which is 1000 kg per meter cube. So this is how you, so I will give one example. If specific gravity of oil is 0.8, then what is its specific weight? The simply take, if you want, take specific gravity and multiply by specific weight of water, which is 9810, you will get 7848 Newton per meter cube. Similarly, if you want mass density of oil, you take its specific gravity and multiply by 1000, which is mass density of water. So therefore, so many of the students, while we're teaching, they get confused about specific weight, mass density, and specific gravity. So you have to be, so specific weight and mass densities has got units, whereas specific gravity is a pure number. It's like one for water. So why specific the specific gravity of water is one? Because the standard fluid is, it is specific gravity is specific weight of any liquid. So specific weight of water divided by specific weight of water only. So therefore it is one always. So specific gravity of water is one. So like this, you should be aware of these things. So another is like this. So for example, here there is you have one way of calculating is that if a volume is given and it weighs 45 kilonewtons, you can calculate specific weight, mass density, and specific gravity. So whatever I taught, the concepts can be put to a problem by calculating like what is specific weight. It is weight by volume. Simply take its weight. So why I multiplied by 1000? Because I want the units in Newton per meter cube. So 45 kilonewton I converted to newtons and divided by volume, I got the specific weight. So here now I can calculate the mass density by the formula. Specific weight is rho into G. So therefore mass density is specific weight by G, which will give you something like 849.47. So now you know mass density of water. So in order to calculate specific gravity, there are two formulas here. So one is specific gravity is take the mass density and divide by 1000, which is 0.849, will be the specific gravity of this oil, because mass density of oil divided by mass density of water, or take specific weight and divide by specific weight of water, which is 9810. So when you divide by 9810, you will get the answer as 0.8495. So this is how there are two ways of calculating. So fast, whichever is it. So I think that this will be more easy, because you always remember that mass density of water is 1000 anyway. So this is, even specific weight of water is very standard, which is 9810. So either you calculate by this or by this. So there was a question in one of the GATE papers to calculate the specific gravity. So given such values also. So there are other properties where we call it as the most famous Newton's equations of viscosity. A lot of questions will be asked. So at least one question will be asked on Newton's equations of viscosity. I will not go to the derivation much into this. So Newton's equations of viscosity states that here, so there should be one the plates, two plates, which are separated by a y distance apart. So now it is filled with the fluid. So now you apply a force which is parallel to the fluid layers. So this is called the shear force. Now, so the fluid that is sticky, because this plate is stationary, this plate is moving with velocity v. So the velocity variation will be, because this plate is at rest, the velocity variation is from 0 to v. So therefore you will get something like a velocity distribution, which is a linear velocity profile if the distance is say y. So now using this, we have from Newton's experiment that force is proportional to a v by y. So where a is the area, surface area of the moving plate, v is the velocity of the upper plate, whereas the lower plate is stationary. Force is the shear force applied. So now I'll not come into the derivation. So this is what is known as this particular equation, which is most famous, known as the Newton's equation of viscosity. So v by y from similar triangles, which can be, so I can, so that's the advantage of using PPTs, because I can go back, I can come back. I've done the animations part here so that you will understand. So whenever I want, I can go back and come back like this. My problems also will be like this. So here by similar triangles, you can write v by y is equal to dou v by dou y. So this dou v by dou y is nothing but the rate of deformation of the fluid, which is also called as a velocity gradient. So velocity gradient dou v by dou y can be represented like this. So v by y can be written as dou v by dou y. So this, therefore, this equation is known as shear stress is known as mu into dou v by dou y. Since this is just a trial class, I am telling a little bit fast. I will later on, when I come to the concept, when I take each topic, I will be covering in detail. So therefore, this is just my sample class, that how my lecture goes. This is how I do with animations like this, and one by one, I just go on living, so that you will go on noting down our important points, so that you can solve the problems. So this dou v by dou y, so this is very important. So which is the rate of deformation of the fluid, or also known as the velocity gradient. And this mu, because mu is simply called the viscosity, which is known as the dynamic viscosity. So here, this is a very important property here is that when I try to apply, so now here this mu is nothing but shear stress divided by dou v by dou y. If dou v by dou y is equal to 1, then mu will be equal to shear stress. So what is dynamic viscosity? Dynamic viscosity is that property where it is nothing but the shear stress required to produce unit velocity gradient. So what is this viscosity? So when you take oil, put it on a glass plate, it will flow easily. Okay, when you take a syrup or a tar or something like that, put it on the glass, but it doesn't move or move easily or flow easily. So why this happens? Because there is always resistance to the flow. The resistance to the flow comes from the shear stress between the layers, shear stress between the fluid layers and the boundary, like this. So if the more the resistance takes place, then the flow is lesser. If the resistance is less, like oil, water, then the flow is very easy. So this type of property is known as viscosity. So viscosity is that property of fluid. By virtue of it, it offers resistance to one layer of fluid over the adjacent layer. So like this, we can discuss a lot of things. So now, if you work out, so these dimensions also becomes very important. So when you try to work out the dimensions from this formula, so now, so what is shear stress? So here when not shear stress, this is mu. Okay, so when you want to work mu, so shear stress divided by dou v by dou y. What is shear stress? Force divided by area. So it will become fl minus 2. So what is dou v by dou y? So velocity is t. What is y? It is the length. So it is divided by length. So length and length cancels, is 1 by t, which is t minus 1. So the unit becomes ft L square. This force is represented as newtons, time is represented as seconds, and this is represented as length is represented as meters, so meter square. So now the unit of viscosity is nothing but newton second per meter square. What is newton per meter square? It is pascal. So it is also known as pascal second. Okay, like this. So now if they ask you what is the unit of viscosity, you should say that in FLT system it is ft by L square, or ft L minus 2. If you want in ML system, then force is mass into acceleration. So now you can express force as mass into acceleration, which is m L t minus 2 into t by L square, which will become m L minus 1 t minus 1. So like this, you can work out, if you know the dimensions, you can always work out the units. So therefore, it is expressed as Newton second per meter square. So sometimes there is also one more term called the poise, which is the unit. So viscosity also measured as so much poise. So you know that one poise is 9 second per centimeter square. So therefore, if there was 10 poise per liquid, so simply divide by 10, it gets converted to Newton second per meter square. So how it comes and all, I have shown it. When I take the class, I will tell you in detail. So one poise is always 0.1 Newton second per meter square. Okay, so this is how. So suppose 8 poise is given, simply take by 10 and get it as 0.8 Newton second per meter square. There's also one more term called the kinematic viscosity. So kinematic viscosity is the ratio of dynamic viscosity to the mass density. So that is represented as nu. So you know that dynamic viscosity and mass density. So you can find out nu. So when you express the dimensions, you know the dimensions of the dynamic viscosity is F TL minus 2. Dimensions of dynamic this mass density is ml minus 3. So it comes as L square by T. So when only length and time are involved, then it is called as kinematics. So you have studied projectiles. When you throw a stone, how much height it goes, how much range it goes, what is the speed at which you throw, like this. You are not involving force there. Therefore, the fluid kinematics deals with the geometry of motion of the fluid. We'll come to that fluid kinematics later on. So only length and time is involved. So when you say length, it is meter square. So therefore, unit is meter square per second. So this is how you express meter square per second, or sometimes it is expressed as centimeter square per second, which is known as stroke. You might have heard of one stroke. Whenever they say one stroke, then it is centimeter square per second. So how to convert into meter square per second? You know, you can divide by 100 square and convert into meter square per second. So if they say 6.4 stroke, you can always convert it to, because I told you, you always work in mass as kg, length as meter, time as second, and also force as the newtons. So these are the units. So whatever units they give, you should try to convert into SI units, because in fluid mechanics, units becomes very important. So when they say that something like dynamic viscosity is given as 0.075 poise, you can divide by 10 and convert into Newton second per meter square. So given the specific gravity, you can always calculate mass density. Then you can calculate kinematic viscosity by mu by rho. So therefore, this is how the procedure is done. So nu is mu by rho. So sometimes they tell you to tick the values of the kinematic viscosity, which you can do it. So for example, here, so something, this is not going. Anyway, I will just try to see this. Okay. So now here, see here. So for example, when I picked it one question from the gate, if the certain liquid has a viscosity of something is not seen here. So this is not going somewhere. Okay, fine. Okay, if a certain liquid has viscosity of 0.052 poise, okay, and kinematic viscosity is given as 3.62 10 raised to minus 2 strokes, then what is the specific gravity, they will ask. So now here, so one of you just directly take this. Strokes is centimeter square per second. So that you divide by 100 square, then it will become meter square per second. This you divide by 10, then it will become Newton second per meter square. Now you have converted this into SI units. So your answer is so 0.44, 0.88, 1.44 or 2.44. So what will be your answer for the specific gravity? So will be the question like. So you should not make any mistake here while calculating. So I told you that viscosity is you have to divide by 10 to convert into Newton second per meter square. Kinematic viscosity, because Stokes is given, you should convert to centimeter square per second. So centimeter square you divide by 100 square. Okay, 100 square, 10 raised to, so it will become 10 raised to minus 6. So what is what is first you should calculate what is dynamic viscosity. So mass density. Once you get mass density, which is because kinematic viscosity is mu by rho, then you will get dynamic viscosity. Take that dynamic viscosity and divide by 1000, you will get the answer. So this is how this very fast you have to solve it and tick the answer. So can anyone tell the answer? What should be the answer? I'll just wind up in 2 minutes, so that these are the things that you know. So what you have to do, first calculate mass.
1.44.
Yes, very good. 1.44 is your answer. So poise you converted, divided by 10, you converted to Newton second per meter square. Stokes centimeter square, you divided by 10 raised to 4. Then you converted to meter square per second. You calculated mass density because kinematic viscosity is mu by rho. Okay, so that is what, and then you divide by 1000 because specific gravity is mass density of the liquid divided by mass density of water. So similarly, the dimensions of the dynamic viscosity are already discussed in MLT system. So you know the formula for that. So the that is nothing but m l minus 1 t, m l minus 1 t minus 1, m minus 1 lt, or it is m lt minus 1. So which is this answer? So already I discussed this. So this answer will be, so dimensions of dynamic viscosity, because Newton second per meter square. Newton is force, mass into acceleration. So like this, you have to try to convert. So you should use your Newton's equations of viscosity. From there you can, or you can also use our this nu is equal to mu by rho, because nu is L square by T, and you can calculate because mass density you know. So directly you will get m L minus 1 T minus 1 is the answer. So this is how you work out the dimensions of the dynamic viscosity. Similarly, if you want, I told you what is the unit. Either you take the unit which is dynamic viscosity is Newton second per meter square. So Newton in FLT system, Newton is F. Okay, Newton second, Ft by L square. So that's why if you know the units, so Ft by L square. So the first is the answer. So like this, there will be. So this question was last year. It was asked in the last 21 paper. It was asked about the dimensions of dynamic viscosity. So I picked this question. So like this, there are a lot of other questions which have been asked in the examination. So this is how we solve the problem. So one of you gave the answer. So we convert dynamic viscosity to Newton second per meter square, kinematic viscosity to meter square per second, and then find out mass density. So knowing mass density, you can divide by if one thing is that you can calculate specific weight and divide by 9810. I will not do that because I know mass density. Mass density divided by 1000 will give you the answer. So which is 1.4. So one of you told this answer. So like this, we can calculate the various problems which comes like this, and there may be a match the following. There may be many types will come. A lot of questions will come as a numerical aptitude like this. So this is how we will go ahead with your a lot of topics in this fluid mechanics, and even in applied hydraulics or irrigation systems, which I will be. So 1 minute. Okay. See here, so one of you see, this is what this was the question that was asked. So I was discussing with equations of first year. So 1 Newton second per meter square. Velocity distribution, which is minus is asked at a distance of 0.45. You know that shear stress is nothing but mu into dou v by y. So what is the answer? Can anyone tell? Will it be 0.9? Will it be infinite? Will it be 0? Will it be minus 0.9 Newton per meter square? Because shear stress is dou v by dou y. Shear stress is mu into dou v by dou y. If you differentiate this, if you differentiate it, yes, very good. So it is 0.9 minus 2 times y. So when dou v by dou y, if you calculate 0.9 minus 2 into 0.45, 0.9 minus 0.9, so this answer is 0. So mu into 0 is 0. So this is the answer. So this was the question asked in one of the gate papers. Like this, if you don't know this formula only, you cannot attempt this particular problem. So that's why either it will be given as a fill in the blanks, or either with this will be given. So you cannot simply tick the one of the answers and you will get negative marking. So that's the reason, so that these formulas become very important and where it should be applied. So here Newton's equation of viscosity can be applied whenever there is one plate stationary, other plate which is moving. So either the piston, one cylinder moving inside another cylinder, a ram moving in a cylinder. So something like this. Or if you have a inclined plane, and then on that you put oil, and then you leave the block. So block is moving, whereas the inclined plane is stationary. Like this, it finds various applications in real practice. So that will be discussed in our classes. So this is what I wanted to tell you about the fluid mechanics. That means my lecture, that the way I deal with the lectures, how I deal with the concepts, and then I start solving the problems. So probably my classes will be like, if I take fluid properties, I will do 1 hour fluid properties, all the fluid properties I will tell in 1 hour. Then when I come 1.5 hours, then when I come next class, I will solve only problems with MCQs. So I will make you to work, and so that you can tick the questions properly. So that is the various types of questions, and then we can have one practice sessions for fluid properties. Then I'll take up fluid statics. I'll tell you the concepts, and then tell you various types of problems that do come for the gates. So this is my way of doing the lectures in fluid mechanics, or whatever topics that I do for you. So this type of animations that I do, and so that writing time will be avoided for me. So that it takes a lot of time for preparation of these slides, but it will come one by one as I write on the board. So hope you enjoyed this lecture, like my lecture. So I will do it in detail when I come for the sessions in due course. Thank you very much for your patient listening.